there is a photograph that changed the way humanity thinks about the night sky. In 2003, astronomers pointed the Hubble Space Telescope at a patch of darkness near the handle of the Big Dipper, a region of sky so unremarkable that it was chosen precisely because nothing was expected to be there. The exposure lasted 11 days. When the image came back, that empty square of black was filled, wall to wall, with nearly 10,000 galaxies. Spirals, ellipticals, strange smudged shapes, we had no names. For each one, 100 billion suns. Some of them so far away that the light reaching Hubble's mirror had been traveling since before the Earth existed. The Hubble Ultra Deep Field, a postage stamp of infinity. It seemed to confirm something we had quietly hoped was true, that the universe is full, abundant, luminous in every direction. But the universe is not full everywhere. Tonight, we are going to a place called the Boötes Void. It sits roughly 700 million light-years from Earth, in the direction of the constellation Boötes the Herdsman, and it is, by any measure we have, the loneliest place we have ever found. The Boötes Void is approximately 330 million light-years across. Take a moment with that number. Light, the fastest thing in the universe, would need 330 million years just to cross from one side to the other. When that light first entered the void on its journey, the dinosaurs had not yet appeared on Earth. The Permian extinction hadn't happened. The oldest trees hadn't grown. The void existed before nearly all complex life on this planet. In a region of space this large, by all expectations, there should be roughly 2,000 galaxies, stars, planets, dust, the slow churn of cosmic time. Astronomers have found 60. 60. The Boötes Void is 97% emptier than the rest of the universe. It was found in 1981 by astronomer Robert Kirshner and his colleagues, who were doing something painstaking and unglamorous, plotting the positions of distant galaxies in 3 dimensions, using redshift measurements. They were building a map, and in the middle of that map, they found a hole. Their language, in the paper they published, was careful and scientific. One plausible interpretation is that a large volume in this region is nearly devoid of galaxies. But the astronomy community's reaction was less measured. It seemed impossible. Many assumed it was an error, a gap in the survey, a methodological flaw. It took 6 more years of observations before a rigorous follow-up confirmed what Kirshner's team had seen. The void was real. It was just that big. It was just that empty. Greg Aldering, an astronomer who studied it, offered a comparison that has stayed with scientists ever since. If the Milky Way had been located in the center of the Boötes Void, we wouldn't have known there were other galaxies until the 1960s. Think about that. All of 20th century astronomy, all of Hubble's discoveries, Edwin Hubble himself peering through his telescope at Andromeda, realizing the universe was far larger than anyone had dreamed. None of it would have happened because there would have been nothing to see. So how does a hole this size come to exist? The answer begins at the very beginning, not just of the universe, but of the quantum uncertainty woven into it. In the first fractions of a second after the Big Bang, the infant cosmos was almost perfectly uniform. Almost. Quantum fluctuations, the fundamental, irreducible jitter of reality, at its smallest scales, created tiny variations in density. Regions that were fractionally denser began pulling matter toward themselves. Regions that were fractionally emptier began losing what little they had. Over billions of years, this process, gravitational instability, sculpted the universe into what we now call the cosmic web. Vast filaments and sheets of galaxies, wrapped around enormous bubble-like voids. The Boetes void is one of those bubbles. Or rather, it appears to be several smaller voids that merged over cosmic time, like soap bubbles combining in a sink. This explains something strange. The 60 galaxies inside the void are not scattered randomly. They trace a faint cylindrical chain through the void's interior, the ghostly remnant of the walls that once divided the smaller bubbles before they merged. And then there is dark energy. In 1998, observations of distant supernovae revealed that the universe's expansion is not slowing down, as gravity would suggest. It is accelerating. Something we call it dark energy, though we barely understand it, is pushing space apart, faster and faster. Inside a void, where gravity is too weak to resist, dark energy reigns. The Boetes void is not static. It is growing. The 60 galaxies stranded inside are unlike most galaxies we know. They tend to be smaller, bluer, quieter, rich in gas, slowly burning out new stars without the disruptive gravitational violence that comes from crowded galactic neighborhoods. A 2021 ultraviolet imaging survey gave us our clearest pictures yet of these isolated worlds, pale, blue islands in an ocean of nothing. If a civilization existed on a planet in one of those galaxies, and they looked up at their night sky, they would see their own stars, and beyond that, blackness. An impenetrable, unbroken dark, stretching hundreds of millions of light years in every direction, with nothing to indicate that anywhere else in the universe there were other galaxies at all. They would be alone in a way we cannot fully imagine.